One small mistake in Nernst equation can flip your answer from correct to wrong in NEET and JEE. In this video, I will make Nernst equation so clear that you will never fear it again. Discuss including derivation and related PYQs. Let's start this Nernst equation. Why do we need the Nernst equation? So in textbooks, we calculate cell potential using standard values like concentration 1 m, pressure 1 bar, temperature 298 kelvins. But in real life, we cannot maintain these standard conditions during the chemical reaction. So in such cases, Nernst equation helps to calculate the actual potential or actual electrode potential at non-standard conditions. See, this cell potential mainly depends on concentration of reactants and products. Where more the reactant concentration, reactants collide more and reaction goes forward more, so that higher E cell value. How it is, we can discuss with mathematical equation. More product concentration means reaction moves slowly and lower the E value. That itself decides spontaneous or non-spontaneous. So this concentration effect is quantitatively given by Nernst equation. This is the important point to understand. Now we just write the Nernst equation directly. E cell equals to E naught cell minus RT by NF log Q, ln Q. ln equals to 2.303 log base 10. So this E naught means standard condition, E cell means non-standard conditions. Here E equals to electrode potential at given conditions, means non-standard condition generally. E naught is standard electrode potential, means electrode potential at standard conditions. T is temperature in kelvins only. N is number of electrons, this is important, transferred. F is 96,485 coulombs per mole. How to get this value? We just charge of 1 mole of electrons. Q equals to reaction quotient. This Q mainly tells how much product by reactants are present at that moment or other than at equilibrium. You might studied it is in equilibrium chapter. Q is nothing but, or QC is nothing but same thing, product concentration to reactant concentration at other than at equilibrium. If it is at equilibrium, that is Kc, equilibrium constant, even that is going to come. So before that, just how we got this equation we can discuss. So the equation we can get it as like this. From thermodynamic formulas or from Gibbs free energy relation, we get the this equation, Nernst equation. You studied this equation in 11th thermodynamics chapter. Delta G equals to delta G naught plus RT ln Q. Here delta G is nothing but Gibbs free energy at other than standard conditions. other than standard conditions. In simple way, remember, wherever not is there, that power 0 not there, those are other than standard conditions. The same thing, standard Gibbs free energy R is universal gas constant, T is temperature in kelvins, Q is reaction quotient, that what we written here. So with the help of this equation we can get it. So Gibbs free energy, there is a formula delta G equals to minus NFE cell. This also you studied in 11th itself. This is equation 1, and delta G naught is same thing, minus NFE naught cell. Here N is nothing but number of electron transferred, number of electrons transferred during the reaction. This is bridge between thermodynamics and electrochemistry. Same these two equations, 1 and 2 equations, can use above equation. So minus NFE cell equals to minus NFE naught cell. Simple derivation, students, not much about this RT ln Q, because without derivation if you do, it is like incomplete. So if you divide, now divide the entire equation with n minus NF, then if you divide, what will be the result? Minus NF and minus NF. Then the resultant is this gets cancelled. The E cell equals to E naught cell minus RT by NF ln Q. This is the equation which we get. So next one, here ln Q we can write it as 2.303 log base 10 Q. So the same thing you can substitute in this. E cell equals to E naught cell minus 2.303 R value. So R you can write as it is, RT by NF log base 10 Q. So here R value is 8.314 joule per mole Kelvin. F is already discussed, 96,485, which can be written as coulomb per mole. This can approximately take it as 96,500 coulombs in the problem solving. Temperature is 298 only, normally also. So if you take 2.303 RT by F, which is equals to 0.0591. So finally what we can get, E cell equals to E naught cell minus 0.0591 by N log Q. So Nernst equation at equilibrium, how it becomes we can see. So at equilibrium Q becomes K, that is reaction quotient becomes equilibrium constant, and E cell equals to 0. Then we can write it as E naught cell equals to 0.0591 by N log base 10 Q. Sorry, it will become K, right? K. So if you want K from this, K equals to log base 10 K equals to N into E naught cell by 0.0591. So from this K you can write it as 10 power n into E naught cell by 0.0591. That's how we can get the K value. Mostly they ask K in the question. Let's learn the physical meaning of Nernst equation. Means how concentration related to E cell value, which I have given starting. The same thing we discuss in detailed way. So physical meaning, there will be cases here. So case 1, where Q is less than 1. So we have discussed the Nernst equation, which is E cell equals to E naught cell minus 0.0591 by n log product concentration by reactant concentration. This is the general way of writing. Here, if reactants are products, pure, if reactants are products in solid or pure liquid, then those not included in Q. If it is in the form of aqueous ions or ions, then only we include in this Q formula. However, the first case is Q is less than 1. So where Q is less than 1, if reactants are more, Q equals to products by reactants. If reactants are more, the Q you will get it as less than 1. When Q is less than 1, log Q, what it becomes, students? Log Q equals to negative. When log Q is negative, just you can use this equation. If this whole term is negative, negative into negative, positive. So what you are going to get, this whole term will be positive. So then the resultant equation is what? E cell equals to E naught cell plus X, which means to get E cell we are adding something. That indirectly tells E cell is greater than E naught cell. This is the case 1, which is very important. Coming to this, we can tell it as cell is stronger. So case 2, where we get opposite, where Q is greater than 1. If Q is greater than 1, what is the result, students? Same thing, E cell equals to E naught cell minus 0.0591 by n log based on products by reactants. So in this case, what is the condition? Q greater than 1 means products are greater than reactants. If products are greater than reactants, this whole term will be what? Positive, which means this whole term will be negative. Correct? This whole thing we can take it as negative. So what you can conclude? E cell equals to E naught cell minus X. So according to this statement, what you can write it? E cell is less than E naught cell. E cell is less than E naught cell. So this is the equation which we get as a result. So here cell is weaker. So we can define as cell is weaker, because here E cell value, if it is positive, E cell value if it is more positive, the process is more spontaneous. Why it is like that? Because conditions for spontaneity, if you observe, conditions for spontaneity, so spontaneity conditions will, so E cell if it is positive, then delta G will be more negative. Delta G equals to minus N F E naught or E cell, because delta G we are taking. So more positive E cell, more negative delta G, isn't it? So when more negative delta G, more spontaneous the process is. So if delta G is less than 0, process is spontaneous. That's how we are deciding or explaining cell is weaker or cell is stronger. Suppose if the condition is equal, where case 3, where Q equals to 1, then what is the result? Product by reactants equals to 1 means here what you will get is log base 10 Q, we can write it as log base 10 1. In the formula what I am taking is just this part. So if you take log 1 which is 0, if it is 0 this whole term will be 0, then what you will get? E cell equals to E naught cell. So this is called as standard condition, means the reaction is happening at standard conditions. Correct? E naught cell is for standard conditions, where the concentration is 1 m, pressure is 1 bar or 1 atm, and temperature is 293 kelvins. Okay, so this is what the equation which we get. These are the three cases. Based on this three cases we can understand how concentration of the reaction impact over the spontaneity or E cell. Next we are going to write the equation, Nernst equation, how to write for single electrode, and later we can write for multi electrode. What is the result? Nernst equation for single electrode. Equation for single electrode. So the reaction is oxidation, potential, so M is M solid converted into M ion plus, it is in aqueous state, plus electrons, n number of electrons, because n plus we have written. So this is an oxidation process. So how to write it? Single electrode, E cell equals to, or E half cell equals to E naught minus 0.0591. Here how many electrons are lost? N electrons, so we are taking as it is n, and log base 10 Q. Correct? So in this case Q, how to write it is Q equals to products by reactants Mn plus by M solid. We already discussed that M solid value will be 1. So what can be written in the place of Q? E cell equals to E naught cell minus 0.0591 by N log 10 M N plus, because this is the product. So M N plus by M. So this you cannot take because it is solid. So that's how we got this equation. So this is what we can write here. Since it is oxidation, we will represent as OX not cell, OXI. So from this equation, this is equals to y equals to c plus m x. So slope will be negative slope, minus 0.0591 by n. And as log mn plus increases, E oxidation value decreases. This is the overall what is the graph. So this is over y axis, this is x axis. So slope will be negative slope and linear graph. So straight line nature proves that Nernst equation is linear equation. Similarly, you can write reduction equation also. Reduction equation. So E reduction equals to, you can write the equation first. M plus n electrons gives rise to M solid. Then Q equals to M solid by Mn plus. So that can be written as 1 by Mn plus, because M solid taken as 1. So what is the resultant equation, students? E reduction equals to E naught reduction minus, plus, you can write minus only first, minus 0.0591 by n log base 10 1 by Mn plus. So which can be written as E naught reduction plus 0.0591 by n log base 10 Mn plus. So concentration should indicate with bracket. So this is the equation which we have got. So here also, so E reduction y equals to C plus mx graph. So this is positive slope, the before one was negative slope. Suppose if you take hydrogen equation, if you take this equation, pH formula derivation, this is also very important. Questions are frequently asked with this. So 2H plus 2 electrons gives rise to H2 gas. So the video little lengthy, but it's more worth. E equals to E naught minus 0.0591 by 2 log. Why it is 2, students? Because 2 electrons. So here water product H2 gas by H plus ions. So H2 gas, because concentration of gas represented with pressure. So H plus ion whole power 2. Now pressure of H2 gas is generally 1 atm. So we'll take 1 atm for this. E equals to E naught minus 0.0591 by 2 log 1 by H plus whole power 2. Correct? So this we can write it as E equals to, because E naught value for SH is what? 0, which we discussed earlier. Correct? So 0.0591 by, in the previous lecture I have discussed. If anyone don't know, you can watch that video. Clearly explained all this. So here log 1 by H plus square, what we can write it, students? Log 1 by x power 2, which can be written as minus 2 log x. So that's what we can substitute in this, minus 2 log H plus. So here this 2 gets cancelled, and finally what you will get is E equals to 0, or you can directly write minus 0. Instead of that, because minus become plus, right? So you can conclude this equation as like this. So E equals to 0, not 0, minus, not minus, plus 0.0591 into log H plus. So which can be written as, because minus into minus will be plus, that's why we are writing like this. So 0.0591 into pH we can write, which is equals to what? E. This is the final equation which we get. So here also we are just writing pH equals to what? Negative log of H plus. Negative log of H plus. So accordingly, if you use pH, sorry, you can write it as negative log of H plus, right? So minus 0.0591 into pH equals to E. This is the most important equation for finding pH. So here the slope of the straight line is, here E is directly proportional to pH, and the slope of line is minus 0.0591 volt per pH unit. These are the related derivations, students. Finally, you need to know only these three formulas. This is one formula, and for Daniell cell, that also you can write. For redox cell, what you can write? For redox cell is very simple. E cell equals to cell minus 0.0591 by n log base 10. In case of Daniell cell, you can take Daniell cell Zn plus Cu2 plus converted into Zn2 plus Cu. This is the equation which we get. These are solids, and these are aqueous ions. This also aqueous ion. Then what is the result? Zn2 plus by Cu2 plus. This is the equation which we get. So this is the equation for Daniell cell or redox cell. So questions are mostly asked with this equation only, but here ions are changed, but questions are mostly asked with this formula only. So the conclusion formula is delta G naught equals to minus NFE naught, and delta G equals to delta G naught plus RT ln K or Q, sorry, RT ln Q. E naught cell equals to 0.0591 by n log base 10 K. Wherever equilibrium is there, E cell will be 0 and K equals to Q. These are the conditions which you are supposed to know. Questions mostly asked with this, and even you should know this formula. Delta G naught equals to delta H naught minus T delta S naught. This is also used to find spontaneity of the process. Right, students? So these are the related derivations and related points about Nernst equation, and we'll discuss questions in the coming video. Please share and subscribe. Thank you.